Hello dear fans. Gamma radiation, what is it? Among other forms of electromagnetic radiation, gamma rays have an unusually short wavelength. For this reason, this radiation has strongly pronounced corpuscular properties, but wave to a much lesser extent. The interaction of gamma rays with matter can lead to the formation of ions. Briefly about gamma radiation. Gamma radiation is a stream of high-energy photons, the so-called gamma quanta. The sharp boundary between X-ray and gamma radiation has not been defined. On the electromagnetic wave scale, gamma rays border on X-rays. They occupy a range of much higher energies. If the emission of a quantum occurs in a nuclear transition, it is referred to as gamma radiation. And if during the interaction of electrons or at the moment of transitions to the atomic shell, then to the X-ray one. But this division is very arbitrary, because the quanta of radiation with the same energy do not differ from each other. Gamma rays are emitted during transitions between excited states of atomic nuclei, during nuclear reactions, during decays of elementary particles, when charged particles are deflected in electric and magnetic fields. Gamma rays were discovered by Paul Villard, a French physicist. It happened in 1900 when a scientist investigated the radiation of radium. The very name of radiation was first used by Ernest Rutherford 2 years later. Later, the electromagnetic nature of such radiation was proved. Gamma radiation and its properties. The difference between gamma radiation and other types of electromagnetic rays is that it does not contain charged particles. Therefore, gamma rays are not deflected in a magnetic or electric field. They are characterized by significant penetrating power. Gamma quanta cause ionization of individual atoms of a substance. When gamma rays pass through a substance, the following effects and processes occur. Photo effect, Compton effect, nuclear photoelectric effect, the effect of pairing. At present, special detectors of ionizing radiation are used to register gamma rays. They can be semiconductor, gas, or scintillation. Where is gamma radiation used? The fields of application of gamma quanta are very diverse. Gamma flaw detection, product quality control, food preservation, sterilization of fish, meat, grain, to increase the shelf life, processing of medical materials and equipment for the purpose of sterilization, radiation therapy, measurement of levels, measurements in geophysics, measuring the distance from the descent spacecraft to the surface. Effects of gamma radiation on the body. The impact of gamma radiation on a biological organism can cause chronic or even acute radiation sickness. The severity of the disease will depend on the perceived dose of radiation and the duration of exposure. Certain effects of radiation may well lead to the development of cancer. However, in some cases, directed irradiation with gamma quanta can stop the growth of cancer and other rapidly dividing cells. A layer of matter can serve as protection against this type of radiation. The effectiveness of such protection is determined by the thickness of the layer and the density parameters of the substance, and also depends on the content of heavy nuclei in the substance. Protection consists in the absorption of a quantum of radiation as it passes through the material. Cosmic rays are considered to be the main source of gamma radiation. The gamma background penetrating to the ground has a very large energy reserve. Beams of this type are capable of damaging living cells. They lead to a cycle of ionization. The destroyed cells are subsequently able to turn healthy components of their neighbors into poisons. Unfortunately, humans do not have any special mechanism capable of signaling the effect of gamma radiation on tissues. Therefore, a person may receive a deadly dose of radiation and not understand it. The hematopoietic system is most sensitive to the effects of gamma quanta, because it is here that the most rapidly dividing cells are present. Irradiation also greatly affects the digestive system, lymph nodes, reproductive system, and DNA structure. Penetrating into the deep structure of the DNA chain, gamma rays initiate the process of mutations. At the same time, the natural mechanism of heredity is completely lost. Doctors are far from immediately able to determine why a patient is feeling worse. The reason for this is the long latent period of changes and the ability of radiation to accumulate harmful effects at the cell level. Thanks for watching.